Okay.
Hello, nice for coming. Thank you for coming. I'm going basically to speak about the HTTP protocol, HTTP2 and HTTP3. I will not really speak about the SSL and TLS. I just have some explanation because all those protocol requires a good crypto, so I will speak about it a little. This is why it's at the SSL here. So press that one. Okay. So what are we going to speak about? I will going to speak about the H3 protocol, which is a new protocol, which is still being, the specifications are still being written. I will speak about HTTP2, which is you can find running on all the servers already. I will explain a bit like how the protocol is selected at the lowest level. I did this presentation last year, but I had more data on the server. I will mostly show things about the traffic server for H3 and for Tomcat for the rest. And I have some small demo that I will try to run. And I hope I have room for questions. So where I am, I'm working for Red Hat. I'm located in Switzerland, and I'm a runner. Every morning I go for a run. Everyone is welcome. We did a few kilometers this morning. I left with some of the guys which were fast, and we make an additional 2 kilometers full speed to see how good it is in Las Vegas to run. It's not so good. Okay, so the new protocol has been started in March. It uses Quick, which is something which was developed by Google, TLS 1.3 and UDP. It's used to transport basically HTTP 1.1, for example, like H2 is doing. So basically, it's going to multiplex the data. I have a slide that explains it a little better on H2. It can also get an initial connection using TCP/IP instead UDP directly, and the server will respond that it had an alternative port. So this is an interesting thing. If your server is enabled, you can have the thing running on UDP on one side, which is working, and then if the browser is able to support it, you can give the alternative response, which is here in this format. So in this case, that's a header. It says that it had a H3 as another protocol and the port where it is running, and it had no host name here, which means it's the same host. The H2 has some problem. Basically, normally the UDP port tend to be closed on the machine due to basically some people were thinking that it's not good for security. UDP is probably slower than TCP in the kernel because definitively TCP is a lot more used than UDP, so there's a chance that some optimization that have been done in the TCP stack need to be done in the UDP one. And it probably needs some extra CPU because basically we need in the UDP you send packet and you don't care if they're going to be acknowledged or not. So you have the issue that you have to have on top of it a protocol in order to make sure you have received everything you need. So this probably going to use some extra CPU. It's based on, it had a 6 RFC that describe the protocol and how to implement a server. So at that point, it's quite good. They are most of them are draft for the moment. So looking at what we already have for for H3, we have curl. Curl since recently support H3 Direct and the switch. Basically, you're going to make an HTTP 1.1 request, and then it will connect back using H3 to another port. We have different libraries which are supporting it. One, NG TCP2, I guess HTTP2. I made a typo here. This is the library we are using to do mode H2 in HTTPD. So there's a chance at some point that we can do something to use it. There's Kish, which is written in another language, which I don't think we're going to be able to use in HTTPD. Curl offer the two library for the moment. You can try if you have to compile curl on your own for the moment. Well, at least you had some week ago. I didn't check today, and you can use the NG H2 libraries or Kish. Kish is another implementation. And in Tomcat, we have one problem. It's like the UDP socket API is incomplete. So we will probably have to use some native code to be able to implement the protocol. So definitively, we need to use one of those two. Probably the first one, because we will have an example how to use it in HTTPD, so we can use this native code in Tomcat quite easily. So actually, in HTTPD, it's not yet there. The people say that once they have time, they will try to work on it. So if you are interested, look to the library, look to how it is done for H2, and then have fun. It's some work, definitively, but it's looked to be doable. And in Traffic Server, they have implemented a prototype. That's I'm going to try to demo very basic stuff because they're going to hope to have it stable enough to release it at the end of this year. So it's quite a big performance. They wrote a lot of code, so that's going to be interesting. So I think I'm going to. The next slide is explaining the demo. So basically, I have a small demo for H2 because for H3. That because this is for the moment there's very little thing we have in the ISF for H2. So I'm going to try to demo what I have. So basically, I have a small demo that uses the traffic server and a modified version of curl. You can play with the browser. Those are linked. So some browsers have been tested. I will let you. I will put the presentation online so you can click on the link and look to the page. There's an interrupt matrix, and Chrome in the past was requiring activation. The recent version of Chrome, they just support H3 by default. So I'm going to try to make a small demo. It's a localhost demo. It does not use itself. So I prepared it because it's a bit tricky. So here I'm going to run the client, and here I'm going to show what is configured in traffic server, and I have a traffic server running. So, I guess it just started. I'm going to sit the other side. J'adore le truc de l'ami, je suis désolé. So, clicking on something.
You hit the token.
Oh yeah, that's no problem. Okay, I'm destroying the configuration file, but that's no problem. I can explain what is in the configuration file. So, basically, to configure a traffic server, you need to tell it that you're going to use UDP thread. You tell which port is going to receive the H2 protocol. In fact, I have enabled the debug because I was trying to understand how it works, and I forgot to stop it in my configuration. On the other screen, the mouse is working. Oh, if it's on, it's better. So on the other screen, I'm going to make. So I have the traffic server running on my laptop on that port, and I'm going to use my own version of curl. I'm going to tell it that I do H2 directly, and I'm going to connect to the traffic server which is running. And I think it's going to work. Hopefully.
Could not connect.
No. Okay. Shit. Well, yeah. I must have stopped the Tomcat.
Oh, it's connecting to a backend Tomcat, all right?
Yes. It doesn't. Yeah, it's working, but it does not. You don't. I want to show the Tomcat page.
Right.
Because the traffic server is, you use it to proxy and optimize your Tomcat. So I need to start the Tomcat. I think that's the only thing I missed. Sorry, give me a 1 second. 1 second, I start the Tomcat somewhere. Push the Tomcat. Here. No output. No. Yeah. So start with Tomcat, and if I redo the request, it's going to go through. If not, I move on. Yeah,
Yay.
so this is the Tomcat page. So this one is working.
And it's proxying using HTTP 1.1?
Yes.
Okay.
Yes, the idea is of all those things is like you have a proxy which is going to do the demultiplexing, and then you can have your normal web app running on the Tomcat, and you can have a normal Tomcat. It's a bit the same in the Tomcat. When you have a Tomcat and you're using H2, and when we will be able to use H3, it's going to be the same. You can still have your normal web app, and basically you get the demultiplexing, and the web app is getting the stuff demultiplexing. Of course, you can have some extension which are bring by the new protocol, but basically you can leave your application unchanged, and you gain the speed of the new protocol. So, I'm returning to the presentation. Hopefully I don't screw it. It's working. Nope, it's in the first slide anyway. So. Okay, so now I'm going to speak about the why. So those are a bit old slide, but I think I can shortly explain what. So why we are looking for a new protocol? Why we created H2? Basically because HTTP 1.1 was started to be quite old. around the time of the Apache Software Foundation. At that time, a server was having something like one HTML page. And now you have one page, you have several also HTML. The page is a lot bigger because it's created automatically. You're going to have image, you have JavaScript, and a lot of other stuff. So to display one page on the browser, you need a lot more elements. So you need at some point to make sure that the page is going to be displayed correctly. Latency is one of the important parts, because when you want to see a page, you want to see it appearing on the screen quite quickly. So to get this, there have been some tries to improve the protocols, basically. Without changing what is inside, we are able to make a big improvement in the way a page is rendered on the browser. And in a lot of cases, you will see, you don't even notice that as an end user, you won't notice that it is used. So H2 is a binary protocol. It uses frame. You can multiplex several connections inside. Basically, when you use HTTP 1.1, what you do, you're going to open. You also open a bunch of connections to your server. With this multiplexing at the H2 level, you don't need that many sockets, because basically you're going to be able to multiplex the data, the different connection inside the H2. As a detail, it's based on Speedy. It requires you to use TLS. Basically, the browser you are going to use are using HTTPS and strong ciphers. There's some testing over that to make sure that you are not doing it. There's no forward proxy planned, but in fact you can use clear text, for example. You could demultiplex your stuff and remultiplex it, and then send it, for example, to it's not completely safe, but for example, you can have your HTTPD, which is going to make the TLS termination, and then you get the clear text to the Tomcat, so that you don't need to do the TSL number crunching in the Tomcat. You must need to be sure that your network is perfectly safe to do something like that, and more and more it's not a recommended option, because basically you never know if someone can enter your network. So, so it's based basically on two specifications, two RFCs, and it requires the application layer protocol negotiation, which is when you establish the connection at the TSL level. I have a slide that explains a little more. You're going to tell the browser is going to tell what is able to support, and the server is going to answer what is taking. So multiplexed, basically it means that you can have some head request in it. You can have basically you can have a get, you can have a post, and you can also push data according to the protocol, and things like Tomcat in the servlet. You can push data that you think the browser will need. You can do the same with Mode H2 HTTPD. So it had some header compression, basically compressing the header allowed to gain some space. It had request priority, because in your application, that way you can decide that you want to display one part faster than the other. And it has a server push. The server push could be very interesting. It's a bit hard to demo, but typically you can, if you think your browser is going to need a JavaScript, you can push it so that you have it. And if you have a JavaScript application, you could push all the image and then have the JavaScript displaying the image later on, and they will be in the local cache, so that goes faster. Unfortunately, I've tried with just a plain text, well, just some HTML stuff, and with some image that does not work. In fact, it put it in another store, and the browser a bit, the specification there are a bit hard to understand, and the browser are not exactly making it easy for you to use it. So basically, all those efforts are to render the pages a lot faster on the browser. I mean, all this effort is basically that when you click on something, you're going to get your server reacting a lot faster. So if you look to the browser, this page is quite old. The version of Firefox and Chrome are a lot more advanced. So I have some stats from last year from the traffic server people. I forgot to ask them this year, so I don't have the data. But on those pages, which are kind of definitively the page with the people that are in the Apache Software Foundation and people that are going to use traffic server have probably updated their browser and their laptop quite often. So definitively, it's not a real indication, but it's mean a lot of the browsers in the world are already supporting the protocol. So definitively, if your server have resources, you don't have to hesitate. You really need to enable the protocol, and it's not very difficult to do. Next slide. So so this is to explain a little the negotiations that this happened inside the just after the TCP/IP connection is established. The TLS is going to send a message. So this is the client sending a message to a Tomcat in this case. In the client hello message, you're receiving all the protocol you are supporting. You can see, so those are some old version of the protocol. This is the current version, and this is HTTP 1.1. And then the server is going to respond with what he is able to do, and exactly what he has chosen. So this is the server hello, and then it's in the extension is telling that he's willing to use H2. So then the connection is going to be in H2. So no, let's see. Yeah, the requirement. So for the tree server, you need a OpenSSL, but that's not really a recent version. Tomcat, you need either Tomcat Native, either at least Java 9. In HTTPD, we have this since a long time, and it uses the NG HTTPD library. Traffic server, the code is in traffic server. So basically, you just need OpenSSL when you are compiling traffic server or when you are installing traffic server, and have a separate OpenSSL installation. So this is the status. Actually, in Tomcat, we consider it as stable. We have had some security issue due to the protocol allowing things which were not very good for the server. Those have been fixed in HTTPD and in Tomcat. So if you are running an old server, you really need to sync to ready to the latest version, because some of those are very easy to create a denial of service by sending some things which are allowed by the protocol but would not be very good for a server. So how you configure it in Tomcat? It's a Tomcat talk, so I'm going to spend a little more time on Tomcat. So basically, you define your connector. This is a bit old example. I don't think this is not. I'm not quite sure it's still considered as safe nowadays. But anyway, you don't need to specify the cipher. Whatever you're using, if it's up to date, it's going to make sure that that the default are safe enough for you. So basically, you just need to add one line in your definition, upgrade protocol, and the class that is going to do the upgrade. So this is encrypted TLS definition, and this is the TLS definition for that's minimum you can write, and this is going to use the NIO connector, and in this case you need a Java which is higher than Java 9. So I think I'm going backward. Oh, I'm going the wrong way. In case you are using Tomcat and you are not using Java 9, some of the people I know that some of our customers definitively want to stay on Java 8. Not always convinced why, but in case you want to run on Java 8, you will have to define this. You have to define the LD library path. That's the path where I have compiled my own Tomcat Native, and basically the Tomcat Native is linked with the OpenSSL. If you are doing it on your own, you need to check that this works okay. If you look to what Tomcat Native is using, it's using the it's using the libSSL, it's using libcrypto, and is also using APA. When we are using the native connector, definitively we need the APA. And this is an example which is not a recent distribution. I'm running 30 on my laptop, so basically it needs to be updated. And of course the OpenSSL. You can use OpenSSL 1.1 without problem. Some Laden, which is not in the room, was doing some fix to make it running correctly. So those are all tests, but I rechecked it quickly. There's no big changes. So basically, the idea is to make some tests in order to have an idea where we are aiming at once we change to the H2 protocol. So you have one test which is using HTTP 1.1 and one test which is using HTTP2. That's the number of bytes that are going through per second, and then that's the throughput. So you can see here what you can see is like you have a little less throughput when you're using H2. So definitively it's consuming some resources. And if I go to the CPU usage, when I look to the CPU usage, there has been some improvement, because really I've been spending some time to improve the performance of the things. So the two curves are a bit nearer now, but it's still something like that. So you still need something like 10 to 20% more resources to be able to do the protocol. Because basically you have to multiplex the stuff. There's a lot of operation to do. So I am going to try to make a Tomcat demo. So did I have something explaining the demo? No. So I'm going to explain it. Yeah, that's a traffic server. Okay. I want to go the right way. So I have an example somewhere in my repository of a server push, but as in fact, the server push does not work very well with the image, because basically the browser will receive it, put it in one cache, but does not use this cache, it uses another one for the image, so basically that did not work. So I would have to write a JavaScript application to display my page, and not a Java, well, I'm not a JavaScript guy, so I'm not able to do it at some point, so it works. Definitively, and that's looking like to be like a good idea to use server push. I can see that it do something, because basically I put in the metadata. If I put in the metadata all the image, which I'm not going to be able to use, which is a bit stupid, but definitively if you use HTTP 1.1, it's going to request these things, but I can't show that it's going faster, so it's not a good demo. But I'm sure that in case you would be able to use the image that you have sent, it would be a lot interesting. And definitively, if you have images that you are displaying through a JavaScript, that's going to work. So I'm going to try to show what I'm doing. So here I have a small. You will be able to run the demo on if you connect. Here you have an open network which you can connect to, and it had to. Once you connect to it, it doesn't have access to internet. Of course, it's just a local thing on my laptop, and this is displaying the address of the two of the two Tomcat. So I have one Tomcat running here, one Tomcat running here, and to make a difference. So this is a box which is local, and on this box at the TCP/IP layer, I have added delay like as if this box would be located in Switzerland. I first ping my server just before coming, and then I'll look at some stats, and I see that it's between 150 to 200 millisecond delay. So basically, what I'm going to show is like if you are accessing your bank, and your bank is local, you won't see a big difference. But if you're accessing a site which is kind of far away, if you use H2, it's going to be a lot better. So I have prepared the page, so I just need to refresh. And I'm going to push. So so the blue is the so let's look to this page a little. So I did the request before going, just in case it would not be working. So and this had taken a lot of time. So I might fail the demo. I refreshed the page, so I'm not sure it would work well. So this is a small plugin to the Firefox. Basically, this indicates that it's using H2. And this is a page made with that's the small Tomcat image, and there's a lot of them. So basically, there's a small JavaScript that counts the time it took to load the page. So this is using H2, and I have another port. So I can show it directly, and then I can refresh them to make it more. Okay, so this was the this is proving the contrary of what I want to prove. So I need to refresh. That's normal. Well, it's the delay I've put is random, plus the even it's not completely local host, because there's a piece of cable. There's the Wi-Fi here in the middle, so it's not always. I'm not always successful in it, and it might just have crashed. Hopefully not. So, okay, this has taken 5 seconds, and if I go to the, so I push this one away and take this one, and then I refresh it. That was too fast. Yeah. It's not going to show what I want. I need a bigger image and a more delay, but it's anyway. You've seen the page is displayed another way because the browser is receiving more. Is not receiving the is receiving the images in a bigger box, and you see there's a difference. I'm not proving my. I need to put more delay. I'm sorry, but trust me, on a real well done website, not on something stupid like that, it's working well. So back to the. I still have some time, or. So. Okay, so moving on. So this is the traffic server configuration. In the traffic server configuration, you define which port you're using. You tell that you are. It's exactly like the little one I was showing with H3. You enable the things. You define in the multi-set. You define the certificate you're going to use. You remap to a Tomcat, and I'm not going to demo it because I have it running on the port with the H2, the H3, and then definitively I have not tried to put the two configurations together, which probably will put me in more trouble than I expected. Next. No. Okay. So I won't show the demo. So let's look a little what is in HTTPD. In HTTPD, you need the module. You need the module mod H2. You define you put it in a virtual host. You define the protocol you are able to support. You force the browser to. Well, you force the answer to be H2 in case you have H2. And then basically, if you connect to the HTTPD, then it's going to use the H2 protocol. One is going to this host, so to this virtual host. I've done some tests here also. You can see that the fact we have the demultiplexing library written in C, it's a bit more efficient than in Java. So the things are, the throughput is quite similar. And if you look to the, apart I have one point which is wrong. If you look to the CPU usage, you can see that it's quite similar. Definitively, I have an issue in my test. The tests are using H2 load, which seems to be not that reliable. So I've redo my test, but it's not any better. So I must have definitively there must be. The problem is when you try to make a benchmark, you always benchmark something else than what you want to show. But I want to be honest. I display what I have. I hate people that make a benchmark and they say, "Oh, you've seen what I've done. I have that amount of data through where you're connected to localhost." No, it's a real test with different boxes. I will next time I will probably redo the test using Raspberry 4 because now it has enough memory, so you can really run HTTPD on it and probably have a real network also, which makes sense. Using also you need a real switch because when you do performance test, you need to be careful that you're not testing the switch, instead testing your software. And yeah, as you know, as the CPU is not going up much, probably one of the issue is like my limitation is my switch, and I need to speak with my manager to get a bigger one and more expensive. So that's the issue. Okay. This I was already showing. Ah no, this is the proxy. I will speak later about. I have a presentation on the proxy. So this is an example of how you can use H2, for example, to do. You can use HTTPD to do the TLS termination because here you're going to do the TLS termination, and you see here H2C. So basically, the HTTPD is going to connect in clear text H2 to the Tomcat, which is running it. Again, if you do something like that, make very sure that your network is completely secure, and always think that your network is never completely secure. So it's an example. It's probably not the best to use. But in case you have little resources, you might have no other choice. Okay, I have a demo which I'm not going to show. Is H2 ready? Yes, it's completely ready. You can use it even if you don't need push. The fact you need to use a Server crypto, but anyway, you need to use a Server crypto. You need, if you are making TLS, you need to make sure that you're using something which is up to date. So definitively, it's expensive, but it has to be expensive. And there's no need to touch the application. That's the interesting part, because what is expensive for a company is to rewrite the application. CPU or memory is not very expensive. It's just going to another department and asking for some money. They surely have it. Rewriting the application is asking some guys to sit and then rewrite the stuff. That's a lot more expensive, and usually that might be difficult. So you can go for it. And I guess that's all I have. Basically, you can find, you can mail me, you can mail the different user list if you need some help. That's the URL where you find the library HTTPD is using. There's also now the library for H3. I have put my demo. I've updated my demo and put it here. And if you want to learn more about H2, Daniel, the guy which is developing curl, have written a book and a bunch of articles explaining very well the new protocol. And I sincerely hope we're going to be able to use it soon. And then, if you have some time, read the book, try the example, and that's quite nice. Now I have, I guess, some time for questions.
How much of a benefit is it to use H2 if your firewall / proxy still uses?
You need to speak a bit louder because I can't hear you.
Sure.
Sorry.
How much of a benefit is it to use H2 if the upstream proxy / load balancer is using 1.1?
Well, basically because the browser are going to be faster. You're going to have more connection on your backend, but you're going to be able to serve the page a bit faster. You need to define your backend in a way that basically you put the static part in one place and the dynamic part in another one, and then definitively when you're going to use the H2, it's going to do the demultiplexing. The images, for example, which are static, are going to be sent probably to the proxy cache and be served very quickly because they're going to be served in parallel. As more or less you have seen in my example, the images are popping, the small Tomcat are popping in the middle of my image. It looks like a bit randomly. So you have some gain. If you generate everything in your backend, I'm not very sure you have a big gain. That's interesting if your pages are cut in small pieces, because you're going to receive more than one request at a time. So it's interesting if you have some stacked pieces, because of course if you generate the stuff, it can put you in big trouble, because you're going to receive a multiple request on the same stuff, which might be disturbing. But usually that have an advantage, because usually you're going to have a JavaScript, a bunch of images, and the part you generate dynamically. So the part you generate dynamically is going to be processed as usual, but the other one can be processed sent in parallel on one connection. So basically, on the proxy side, you're going to spare up some socket, and as the end result, the running of the page is going to be a bit faster. Then you need a little more you need some more CPU, so you have to choose whether you want to do it or not. Does that answer the question?
In your performance graphs, especially for Tomcat, it was pretty clear that HTTP2 is actually slower than HTTP 1.1 and requires more resources.
Yes.
So, given that, what's the benefit of using H2 instead of HTTP 1.1?
Well, it's just like the idea is to run the page faster. The one that invented the protocol, I don't think they care a lot about the server.
Okay.
Yeah, basically a trade-off server resources for better latencies for the end user. And HTTP3 is going to be even worse for that. It's probably going to use even more resources on the server, but get even better latencies for the end user.
So the throughput is slightly lower, but the latency is also lower.
Yeah.
Okay.
Yeah, basically you need to add more servers.
Yeah, if you look,
Like Google will add more servers to them, but Gmail will run a lot faster. Like it will feel like a local desktop app, and instead of some remote thing.
yes, basically you're going to put.
And probably they're going to use H3 for their stuff like Stadia and whatever. Also, I guess for the end user comments, stuff like that.
Yes. If you look to this.
Just making guesses, of course, but
If you look to this slide, you quickly, for example, if you do a lot of get, for example, if your browser is like the image the page I've shown, which have a lot of small images, all this is going to do in different in the same socket, and it's going to be multiplexed inside. There's some parameter to prevent the multiplexing to go too big, which was one of the limitations of the H2 protocol, where you can crash the server or cause a denial of service if you create too many of those. So there's some parameter to prevent this. But basically, you see, you can have a ton of those which are going to display to allow the page to be rendered on the browser a lot faster. But definitively, there's a limitation here, because here with H2 we use TCP/IP. So basically, TCP/IP is going to at some point to slow the browser and to slow the rendering, because basically if you have one of those which is slow, like imagine here some of this data is generated a bit slowly. You might block. You might block the multiplexing, because TCP/IP has a windows of acknowledgement. So at some point, if you're not reading fast enough, you lose latency. So the idea to get something better, this is why they're moving to TCP/IP, because all of this is not in one socket. It's going to if you have space, you're going to be able to send. So the browser is going to be able to send on one if it's processing the data. If the other one is not processing the data, it doesn't matter. The packets are going to be lost, and then at some point the protocol is going to ask to get those protocol resent when it's going to be able to process that. If you use TCP/IP, well, if you're not processing the data, you block the old thing. So that's one of the limitations you see quickly in the H2 protocol. So this is why we moved to H3, which use UDP, which should fix that latencies. But definitely that's going to make the server work a lot more difficult. And plus probably the kernel, because UDP is not as used as TCP/IP.
So I'll ask it again and have you just repeat what you just said, which was, what's the motivation for building H3 if H2 already looks good? The answer is to further reduce the latency.
Exactly. So basically, you feel better on the browser, but definitely you need a lot more on the server.
But yeah, with H3 the complexity is even worse because you're mixing TLS with UDP and it gets a bit crazy. So
yeah.
so that's why we are not going to do it in Tomcat apparently. So it's going to be in an external library.
Right, because Java,
No.
the Java UDP,
No,
it
it-
can't support it, right?
No, it doesn't have the API is to mix UDP with the TLS thing. Basically, we need to mix JSSC with the UDP
Yeah,
code.
because you will need to encrypt the packets themselves, so you receive a packet and then it's a bit difficult to do that in Java. Well, with the so we will have a library that will do that for us, like we do for H2 in HTTP. That's all I have. And I guess I've